Alright, so this video is going to be on factorizing using perfect squares. So with the previous video, we had a look at how we could expand using perfect squares. We're going to look at factorizing now. So let's just recall what the rules are for perfect squares. So we've got a plus b squared and a minus b squared. The formula was that whenever we have this particular type of form of expression, we can say that this turns into a squared plus 2ab plus b squared. Likewise, with the minus sign in there, it just turns into a squared minus 2ab plus b squared. So what we need to do is, if we're going to be using the reverse in this case, there is one condition that we need to make sure that we satisfy before we can assume that something is a perfect square, and that's the fact that we have to calculate what the 2ab is first with the things. So what I mean by that is that we'll take this over to an example. So you can see with this first particular one, it's x squared minus 14x plus 49. What I'm going to do is I'm just going to change color. Let's have a look at what the a value in this case is. Let's have a look at the a value for this case. Well, the coefficient of x squared is just 1. So the a value is just 1 in this case. And what is the b value in this case? Some of you might think that it's 49. However, we need to be quite careful with this. And I'm just going to rewrite this as 14x plus 7 squared. Okay, because we want to reduce this down to a perfect square, so we want to follow the form of b squared. We'll keep looking at that in the other examples. So in this case, b is actually 7. So what I mean by the 2ab aspect of this, if you can see at the top, you've got a 2ab here. What we need to do is we need to check first that if we go 2 times whatever a is times whatever b is, that it actually comes up with whatever our question says. So let's just check that in this case. So what's 2 times 1 times 7? And that would be 14. And that means this case we have a perfect square, because 2 times a times b does equal that number in the middle. Let me give you a counter example of how this would not work. So I'm going to use a green pen. So let's just say, for example, the equation was x squared minus 16x plus 49. In this case, it would not work, because if we compare these two ones, when we have 2ab, what we get is 14. But in this case, it's 16, and this one it's 14. So that means this one is not a perfect square, but this one is. Anyway, let's go back to the particular thing, and so this reduces down to, sorry, I'm just going to rub this out because that's not supposed to be there, and I'm just going to rub it out. So it reduces down to x plus 7 squared. Alright, let's look at the next example in this case. What we have is x squared plus 9x plus 16. So again, let's calculate, let's rewrite this equation. I'm going to rewrite this as x squared plus 9x plus 4 squared. Okay, and that condition that we had to satisfy first was the 2ab condition. So what is the coefficient of x squared? The coefficient of x squared is 1, and the coefficient of b in this case, sorry, not the coefficient of x, sorry, the coefficient of a, x squared. The coefficient of x squared is 1, which is our value for a, and the coefficient for our of b case is just. So the thing we have to check out now is what is 2 times 1 times 4. In this case, we have a value of 8, which is not what we had in the original question, which means it's not a perfect square, which means we can't use the rule of just simply condensing it down in this case. So we're going to move on to the next question now. Next question, let's rewrite this equation as x squared minus 18x plus 9 squared. again, let's satisfy the condition of 2ab. What is our value for a? What's the coefficient of x squared in this case? It's just 1. The coefficient of the c term, or the last term, is just, so b is just 9. So let's check out the 2ab. So 2 times 1 times 9, in this case 2ab is equal to 18, which means it is a perfect square because it satisfies whatever's in the question. So once again, since it's a minus, what we're going to do is we're going to implement the a minus 2ab plus b squared rule, which is the same as saying a minus b squared, which means this reduces down to, this question reduces down to x minus 9 squared. Now, let's look at the next few questions here. The next few questions have a different coefficient in front of the 4 in this case. So what we're going to be doing is, let's rewrite this thing as 2x squared plus 12x plus 3y, and all of this squared. So from here, if we were going to label what our a value is, our a value in this case is 2 and our b value is 3. So if we check what 2ab is, in this case we have 2 times 2 times 3, which is 4 times 3 is 12, and in this case it does satisfy what this is. So therefore it is a perfect square. So this reduces down to whatever this is, so 2x plus 3y squared. And likewise with the last example, doing exactly the same thing again, reducing this down to 3y squared minus 30xy plus 5x squared. So this reduces down to 5x squared, and so from here we look at our a value. Our a value is 3, our b value is 5. So what's 2 times 3 times 5? And that is equal to 30. So therefore it is a perfect square because it reduces down to that. So this will become 3y minus, because there's a minus right there, and that will be dropping down here. This will be 5x, all that in brackets, squared. Now as an exercise for you, if you're unsure of your answer, always double check what this would be in expanded form. So for example, 3y minus 5x, 3y minus 5x. If you use FOIL again with this term, what you should do and what you should find is that you should always get the original question in return. So let's move on to the next video on factorizing when in general cases.